Okay, so today we're going to look at transformations using matrices. So we've done a bit of matrices now, so we know what to do. And if we looked at, the last thing we looked at was simultaneous equations and setting them up in matrix style. So what we're going to do, it's going to link in together. So if you remember at the start when we were doing some transformations, and remember I would say, all right, what's happening to our x value? And say, for example, if we, you would say, oh, there's a dilation of 2 in the y-axis. So you said, all right, that made the normal x times 2. Remember we were doing that, and then you rearranged it. Do you remember that? Yeah? So what we're going to do with transformations, if you look, we can say that. We're going to set up an equation, and really we'll say what happened to our x, and then we have a little thing, and then what happened to our y. So we're going to use that, and then you can see you get sort of like a simultaneous equations. So if we had these two equations like that, and you set it up simultaneously, remember we had, we put the numbers in the first matrix like this. So I'll just do a little example. So when we had 2x plus 3y equaled 5, or 5x plus 2y equaled, I just made that up. To set them up in matrix form, remember we were putting them in numbers, and then you do times the x and the y, and you say equals the 5 and the 8, like that. That's how we were setting it up. So I'm sort of showing you, we're going to do that here. You can see here we're doing that. We're setting them up using these equations up here. Okay, so if you have a look, so when we set that up, the numbers are put in here into this matrix, then we have x and y. So what I'm saying is, so this was your, if you're talking about transformation, this was the original point, and then we've got the new point, which would be something's happened to the x and something's happened to the y, some type of transformation. So this will help you realize that now. And remember, if we practice, run and dive, that would produce that formula, those equations. And if we did run and dive, that would produce that. So it shows how you can set it up in matrix form. So really, let's have a look. So we're looking at our transformations. So if we look at a reflection in the x-axis, remember that made the y negative, didn't it? So if I want that to happen, if I want to do that transformation, what I do is I set this matrix up here. So nothing happened to the x. So if you have a look, the x. If I go, so I'll just do it right now here. So say I use this matrix, okay, and say this xy was my original point, okay? So you can see when I do that and I go run and dive, this one will end up being, it would have been x, or 1 times x plus, oh God, that's very unclear, sorry. 1 times x plus 0 times y. And then you do the next row and column, so row and column, and you would have seen 0 times x plus -1 times y. Now see if I tidy that up, wouldn't you just have x, because 0 times anything is 0, and then negative y. Does that make the point like we would want to see it? Yeah? With that reflection, can you see that? So using this matrix here would give you a reflection in the x-axis. It makes the y negative, which is what you want to see. So then if you look at the next one, if we want a reflection in the y-axis, that means the x becomes negative. So can you see, I'm going to use this type of matrix where the x value will be times by a negative, and then we just want the y down here to be just itself, so it's just 1. Okay, now if we are looking at a dilation factor, of k from the x-axis, remember that affected the y value. So can you see I'm going to times, this is where the y spot is. That's where it'll affect the y. So it becomes k there. And then if it was in the y-axis, you see it affects the x. So then you affect. So really, when you've got the matrix set up, this is the x spot, isn't it? This is what affects the x, and this is the y spot. Does that make sense? So if you want to do something to an x value, it should be happening up here. If you want to do something to the y value, it should happen down in that spot. Okay, so if we want to, but that's just sort of doing dilations and translations. If you want to do, say down here, a reflection in the y line. Do you remember that was the inverse operation? Remember finding the inverse function? Do you remember that? Remember the inverse function and you let x equal y and then you rearranged? Do you remember that? So that, when you want to do that, we do this. We swap and we put the 1 and that will change it for you. All right? Now, this last one is a column matrix here. That's when you want to move it left or right. So we might say you want to go, if you wanted, say, the new one, we say we do dilate or translate the graph 3 units in the positive direction. So you would have said, all right, it'd be x plus 3, yeah? And say your y, I don't know, remained the same. So what you're going to see is you'll have your normal transformation. So because I haven't done any dilations or, what do I say? Dilations or reflections. So you'll just keep them normal. You get that, but you also then want to add 3 to it. So we'll go plus 3, but we don't want to move the things. So that's how that'll end up being. Okay, so let's have a look at this example 11. It says, consider the linear transformations such that, so this was the original point, yeah, and then when it got changed or transformed, the point went to that. Okay, so what happened, we know, well, when we do a transformation, we know that this is the original point, so see there, original point, and we times it by a transformation matrix. So we don't know what it was, so I've put letters in the spots I don't know. But I know the answer essentially was that. So when I times A, B, C, D, when I times it by the original point, so that's the transformation matrix. When I times it by that, they said the answer was 2 and -1. This is the image point here. Okay, so can you see if I do run and dive, what I would have got was A times 1 plus B times 0 equals, would have been this 2, yeah? And what does that simplify to? That would have been A equals 2, doesn't it? Yeah, so now we've worked that one out. So now if I look at the next one, if I go run and dive, that's how we multiply, it's going to equal that. So I go C times 1 plus D times 0 equals -1. And what does that work out to be? C equals -1. So at the moment, I've got this, I know what that is, and what else do I know? I know what A is, all right? But they gave me 2 points, so I can do the same over here and work it out. So they would have been, if you do the first one, run and dive, that would have been A times 0 plus b times 1 equals -3. So we've just got it here. We could put it there, it doesn't matter. So see this was the image, this was the original point. It got times by this transformation. So you can see there's the original point, and it got times by this transformation matrix, and it gave us the image. So I'm using them to work out the what the letters are. So now if I do this one, run and dive, I would end up with C times 0 plus D times 1 equals 5. So I know that D equaled 5, and also that C, and what was the other one? B equals -3. So now I have all the answers for my transformation matrix. So we know that the transformation matrix, we've got it now. We've worked that out. It is actually going to be A is 2, B is -3, and C is -1, and D is 5. And they asked us in the question to find the image of that one. So that means I'm timesing that point by this transformation, and I'm going to get my answer. So which would be, sorry. Okay, so remember, just to help you, we're going to go run and dive. So it'll be 2 times -2 plus -3 times 3. And then the next, if you do run and dive, it would be -1 times -2 plus 5 times 3. And just tidy that up. What's -4 plus -9? -13. You happy with that? That's this bit. And then the next one would be, what's that, +2 plus 15, 17. Yes? Let's do this example 12. So find the image of the points -2 and 4. So this is the original point, okay? So for us, this is what we call just normal X and Y. Now, it's a reflection in the Y-axis. Remember, that makes X negative, doesn't it? Yeah? So see here, we did that here. And it followed by a dilation by factor K from the X-axis. That affects the Y value, doesn't it? Remember, that's the reverse, the annoying way. So, because I want the X to be negative, this number here, the number 1 here, will affect the X. So I just want it to be negative, so I'll just make it negative. Now the K, because we want the Y, we would really have K times 1. We don't need to have the 1 there, do we? Which is why that's not, you can't see the, like, so really we said it should be 1 times K. We've left the 1 there and we put the K. Okay, so you know that's your transformation matrix. You've worked out what you need. So there's your transformation matrix. You know that's the one you're going to use. You pop it, you times it with the original point like that. So this is the original point, this is the original X, this is the original Y. And then you do like what we've been doing, run and dive. And if you had a look, I'll just type that out for you to show you. So to manually do it, it would have been -1 times -2 plus 0 times 4. And then the next one, run and dive, it would have been 0 times -2 plus K times 4. And when you tidy that up, doesn't that become +2 plus 4K? Yeah? Can you see how I got that? And there we go. All right.